We actually have a project with Lentils that was funded by the Northern Pulse growers, and basically with the Lentils, and this is some of Michael's stuff he'll talk about, but they just, you know, for the background, I'll talk about lentils here. With this project, as well as the one we'll talk about in peas, the theory is you have to know your enemy. And so we're doing both of these projects not only in conjunction with Michael, but also in conjunction with Kevin's breeding program. And so in order for him to breed against the pathogens that are problems for our producers, we have to know our enemies. And with Ascochyta lentis, some research has been done in other areas, certainly in Canada they've looked at some of this. The pathogen can change, and in some cases can change very rapidly. And what we don't know here in North Dakota and in Montana is exactly who our pathogen is. We know we have Ascochyta lentis, but we can have two mating types where the fungus needs a partner of the other mating type in order to produce sexual structures, and the production of sexual structures will allow for that pathogen to gain resistance over either our fungicides or our host resistance. It can allow that to happen in a more rapid manner because you have remixing of genes when there's sexual reproduction. And so we don't know what our mating type structure is and what our possibility is for remixing of genes. And then we also don't know what our pathotypes are within just an asexually reproducing population. And depending on the pathotype that we have here and that we have in neighboring growing communities, will make a dramatic impact on how and what pathogen, what population that Kevin is using to screen his germplasm. And so we're working on not only collecting isolates, as I said with the chickpeas, we're going to be out in the next couple of weeks collecting isolates, and so that we can get an idea. In that case, we're trying to know our enemy as far as the fungicide resistance is concerned. There's been some work done on the pathogen population in Ascochyta rabii, and so we know a little bit about that. With lentis, we really don't know. And so we'll be out in the next couple of weeks collecting isolates and then working in the greenhouse over the winter to determine what our pathogen population is. Also in regards to kind of really lending Kevin a hand as far as his screening is concerned, we have a project going where we will evaluate 3 different types of greenhouse inoculation methods. There's been a little bit of work done about each of these 3 methods, but never really together, and never really relating how those methods reflect what's happening in the field. And we can all do all the work we want to in the greenhouse and in the laboratory, but if it really has no correlation, no relationship to what's going on in your field, it's not doing you any good. And same thing for Kevin. If we can make some greenhouse testing method, but if it has no correlation of what's going on with his selections in the field, then that really is doing us no good. So we will evaluate these 3 methods, one of which is a detached leaf assay. And so as Kevin's producing lines and we know, minimal pods in trying to increase seed, if we're taking some of that seed and destroying entire plants by inoculating them with the pathogen, then that's just setting his program back even farther. And so if we can do a detached leaf type assay and pull 1 leaf off a plant, or maybe 2, or what the case is, and inoculate that and determine the level of resistance in that line, in that way, now he can grow that plant to maturity and have that seed to use, or use it for another assay that he's going through his program and what the case is there. So those are really kind of our goals with lentils at this point. It's kind of what we're starting to focus on in our first year, and going forward we hope to really be able to aid in that selection of genetic resistance. We also will look at the Ascochyta lentis population for fungicide resistance, and that's something that to me is, although we don't use a lot of fungicides, we have to remember that if we use one fungicide one year and we apply Proline, if we apply Proline the next year, that's a sequential application of fungicides. And so we have to keep that in mind. And I know Michael was talking about the Endura Priaxor, and Priaxor possibly being good opportunity going forward. We have to remember also that the same class of chemistry is a sequential application, and so you really need to pay attention to those FRAC codes and make sure that you're alternating FRAC codes, not just alternating brand names. I would like to add that I'm happy to have any discussions with producers. Being new, I really need to get out and look at fields and be happy to take any samples that you have and have a look at them. We really need to stay integrated. I don't want to be the person who stays in my lab in Fargo and never gets out to see the producers. So unfortunately it's a long ways away and we don't have the opportunity to do that as much as we'd like, but we will be out and try to do it here a little bit. So.
Okay, the trial you see behind you here is one of a series of trials. You're going to see, we passed one right past the chickpeas. Looked very similar. You saw the risers, you saw the lentils, you saw actually the little plots too. And what we have is we have a set of these scattered around this area. We have another one about 3.5 miles due south of here, right by town. We have another one about 2 miles south along the highway. And then we have another one that's about a mile and, no, I would actually say maybe about 3/4 mile south of here, okay? And each one of these is targeting a different foliar disease. And the genesis of this project was the 2011 growing season, which you guys may remember was wet. Very, very wet. And in that season, it became apparent that our disease problems of lentils were much more complicated than just Ascochyta. Yes, we have Ascochyta, but in large areas of the state, especially up in the Ray area, this is the center of lentil production, we have a lot of anthracnose. In some areas of the state, when it's wet enough, we have botrytis. Sclerotinia is actually pretty common, and when you have late rainfall events at that mid-pod period, you can get a disease called Stymphalium blight, which I grew up out west. I kind of think of as the forest fire of lentils. It defoliates the lentils, leaving just sticks, sort of like a forest fire. You know, it comes through and burns off all the leaves, and you're left with sticks, right? That's what Stymphalium blight does. And I tell you, it's surprisingly easy to find these diseases. Just last year, which was not as wet a year, still was fairly wet out west. When I was out at Nesson Valley for the irrigation day in the 3rd week of July, I took some time, I had a little bit of time, and I looked at a handful of lentil fields. And I can tell you, I looked at I think 4 or 5 lentil fields, and I found Sclerotinia in 2 of them. I actually found a patch of Stymphalium blight that caused rather moderate. It was a moderate level of defoliation in one of those fields. So these diseases are out there, and what our objectives here in these trials is we have 3 objectives. One is to screen fungicides for the efficacy. Okay, and that on the surface would seem like our primary objective. Okay, but parallel with that is also an effort to assess what the impact of these various diseases are. We know from the work done in Canada that anthracnose and Ascochyta are serious problems, okay? What is less clear is how much of a problem is Sclerotinia causing, how much of a problem is Stymphalium causing. Stymphalium hits awfully late in the season, it causes defoliation, and in many cases, it almost seems like it just hastens the maturity of the crop. It's almost like a harvest aid in a way. And I don't know how much is hitting the yield. So what we are attempting to do here is if we successfully screen fungicides, what you end up with is different levels of disease in different plots. And the plots are very well characterized for their disease levels. And what you're able to then do is relate different levels of disease to different outcomes in terms of not only yield but also seed quality. So seed discoloration and seed wrinkling and seed-borne disease. That is a second objective here. A third objective is you tell me what fungicide most producers are using on lentils. Headline, rotated with headline usually, occasionally Quadris. Okay, and these are both QOIs. They're both Strobilium and QOI fungicides. And at this point in time, it's working for us. Okay, but there comes a certain point at which you should expect that you will select for resistance. Okay, and at this point in time, headline's working great, but we also need to, I think, as a research community in service of the producers, we have to be thinking down the line here. We know that Ascochyta on chickpeas has developed resistance to headline, right, and other QOIs. There was a report out of Canada, I think in 2012, the Ascochyta on field peas has developed resistance to the QOI, detected in a part of, I believe, Saskatchewan.
Yes, yep.
Right? It follows logically that Ascochyta of lentils is high risk. I'll be the first to tell you, headline is the best product that's registered, hands down, for disease control on lentils, with exception of sclerotinia control, which is this trial behind us, okay? But for the rest of the diseases, it's great. There's a reason why people use it. What I'd like to do, at least in service of the producers, is realize that sometime down the line, given the current practices, we may very well lose headline. And if and when that happens, I'd like us to have another tool in our toolbox. Okay, and so we have been working aggressively to screen other compounds, and we did find one product that has shown some promise, and that's Omega. That's active ingredient fluazinum, a completely different mode of action, and it showed some really good promise in our trials last year. And we have funding here from the pulse growers and also the Department of Agriculture Minor Crop Protection Product Harmonization and Registration Fund, which is also known as the Minor Use Fund. So the combination of North Dakota tax dollars, combination of that and your checkoff dollars. And we're following up on the Omega. If we have another year of good results from Omega, we'd be hoping to get a registration through IR4. And I'll tell you, the registrant of Omega was sufficiently impressed with the results that he is now funding trials in Washington State and Montana to test this as well. And I believe he put some trials out in Canada as well. And so it looks promising on the lentils, but we need more testing. But again, this is just looking down the road to try to make sure we have a tool in our toolbox in the event that we lose headline. Okay? So those are our objectives. This trial behind us is looking at sclerotinia. You see the short plats there. That's a germplasm screening that we're doing for Kevin McPhee. But this is our sclerotinia trial. The one you just passed the chickpeas, that's our anthracnose. At this point, the anthracnose is just getting started there. The Ascochyta trial is down by the pasta plant. And I tell you, this year's been very dry. Last year was very dry too. And we managed to get disease because we, if you see, oh, the truck's gone now, but we have a 2,000-gallon tank that's hooked up to a truck. And what we did last year, and we did it again this year, is we actually fill up that tank, we bring it out into the sprinkler system, hook up a pump, and pump water through the system, usually around 9 p.m., so that the leaves are wet all night. Okay, and then we try to hit it again in the morning if we can. Some nights we're too tired, but some nights we're able to do that, okay? And inoculate. Last year we got gangbusters results doing that, okay? But we also got helped out because we got a few rain events. I'll tell you what, I about killed myself last week over the 4th of July weekend, and I was out here, I was putting on 1/5 an inch of water every night, ending anywhere between midnight and 2 or 3 in the morning. And I don't know, I was a little bit bummed here. Michael put on the second fungicide app, Michael Schaefer here on Thursday, yesterday, and no disease. There's only so much you can do to create disease when the environment's not favorable. I still have a little bit of inoculum left, so we'll give it another shot here this weekend and see if we can still make something take out there. But as far as these diseases, I'm quite a bit more confident with these. Lentils melt in front of sclerotinia. If there's any sclerotinia pressure at all, they are very, very susceptible. And the anthracnose, we've never had problems establishing anthracnose. Anthracnose likes it warmer than Ascochyta, and so we should get results with those. Stymphalium, I'm crossing my fingers, and botrytis, well, it's been warm, but we'll try. The question was, what did I see for disease pressure in the pulse crops in western North Dakota? And the answer is that the field peas that I looked at generally looked pretty good. Okay, I saw one field that had a moderate level of bacterial blight, one field that had a moderate level of Ascochyta or Mycosferella, as you, whatever you want to call it. In this case, it really looked like the Mycosferella because it really had the target-shaped lesions. But in neither of those cases did I feel like it was economically going to be a problem. Okay, and the lentils at this point still look good. I did see some Ascochyta, but the question mark, at least in my experience, and Kevin, you may be able to add to this, but my experience is that at this point in the growing season, the lentils typically look pretty good. The question mark comes if these rains persist, the rains they've had out west persist, then your lentils are not going to dry down by the end of July. Or sometimes they won't. If they do not dry down because you get too much rain, that's when they start to look kind of ugly because of the disease a lot of times. I don't know, at this point in time they look all right, but when I have seen problems, the disease has really set on more around that third week of July is where you really see it, okay? And I've typically only seen it get ugly in the fields that did not get a fungicide application around, presumably it was around bloom initiation. You can always tell only just because you see the tire tracks. And the other fields typically look pretty good even then.
Root rot wasn't an issue with this cold, wet spring?
I saw some Fusarium root rot on some field peas, but it was not anything that I would call tremendously bad, but I didn't look at a ton of fields. Kevin?
I had one call from south of the Minot area, I guess in the Newtown area, where a grower called, said he had a couple of acres around the edge of the field that were yellow, short, looked like what he described to me over the phone sounded like root rot, but that's all I've heard. It's just that one call.
I guess, Michael, too, one of the things that Blaine and I were just talking about is a lot of the new peas are not resistant to powdery mildew.
Oh.
And certainly this is a year, at least in this plot, and I'm sure you've seen it, Kevin, over in the peas, is the powdery mildew is starting to come in, and you know, late seeding, warm temperatures, that kind of thing. So a lot of growers should be aware that they should probably be looking for it.
Well, I can tell you at this point in time, what I looked at looked good. Okay, and I would not expect anything to go down on the peas at this point, unless the powdery mildew came in, right? And
I'm looking forward to a good year for screening.
As far as the lentils are concerned, I think it's only a question of whether rains persist and the lentils don't senesce down at the end of July early August like they should.
In all your work, a lot of growers that I talk to say the fungicide's not working, it's questionable, it just doesn't seem like it's positive all the time.
Yeah.
How much work have you ever done comparing the fact that a lot of growers are using the wrong nozzles to put their fungicides on?
Applying with flat fan nozzles. Okay, we use flat fans at 35 psi, and we're testing at 15 gallons an acre. Okay, and I guess tell me exactly what type of nozzles are they using for the herbicides?
Well, they're using the flat fans, and what I'm trying to get across is that they need to go to a fungicide nozzle, not a herbicide, to put fungicides on.
So, are you talking like an air induction nozzle, or
no, like a hollow cone?
A hollow cone, okay. We're still getting good control with the flat fans here, but I think that probably some of the problems people are running into is, I mean, what I have seen out there, to be honest, is sometimes the timing isn't, many times the timing isn't optimal, but also what I see many times is that a producer will say, well, I don't have good disease control, but I walk out there, what I've seen is a lot of sclerotinia, okay? And so the anthracnose and ascochyta are well controlled, but if you apply headline, you aren't going to control your sclerotinia.
Right.
Okay, and so sometimes it's disease identification, and that's part of the reason why I think it's important to know what the yield impact is, for instance, of the sclerotinia, and the quality impact. And at this point in time, that's a bit of an open box on lentils. And what we are doing to do this is we're controlling the other diseases. But we've had good success with the flat fans. I don't deny that the hollow cones and the, say, air induction nozzles have some advantages. I've heard that. You look at our disease control results that we've gotten for anthracnose control and ascochyta control, and you look at last year's results, we had 500 pounds an acre on our non-treated check on the ascochyta trial, and we had, I think, 2,800 pounds on the headline, and it was the difference between about 2% necrosis, canopy necrosis, and about 85-90%.
I congratulate
so,
you on what you've done. I
Well,
think there's another step forward
yeah.
in where you can
Yeah.
go.
Yeah.
And when you specifically put the micron test to what you're trying to do,
Yeah.
I think you'll see another increase in yield.
Well, and I appreciate that feedback, and we will, going forward, I will look into developing some trials to look at different application technologies. But I guess what I'm trying to say is that I don't think it's all the nozzle, because
Put the right chemical with the right nozzle and the right timing, there's where your success is going to be.
sure, and the sclerotinia, I'm not convinced that we're going to be able to control that with chemical, to be honest. And what's surprising is that there actually is a fair amount of sclerotinia out there late season if you get the rains and if the canopy gets pretty dense. Very, very happy to visit with you, and I will very happy to develop a protocol out here where we can test exactly that, and hopefully do it out west as well.